All right, so on page 15, we're going to now look at equations as functions. We talked about looking at ordered pairs, looking at graphs, mapping diagrams, and things to determine if something was a function, if a relation was a function. But equations can also be functions. Functions can be represented by an equation, which basically the equation is a rule that tells us what we're going to do to the numbers we put into the function and then to get a certain number out. So the equation will generate ordered pairs by taking an input that results in a certain output. So for instance, and you might see this notation, for example, instead of a y. You might see something that says, when we read this, we read it as f of x. So it's like the function is called f, and maybe that function says we're going to take 3 times x and add 2. Yes. And so the numbers that we put in for x are the inputs. And then what the answers we get are the outputs. So the f of x is the same thing as if I just wrote y is equal to 3x plus 2. So the output is another name for the y. So we have talked about x and y, and just as a little refresher, we've talked about x being the domain, y being the range. And then we can also say that the x's, they are inputs, and the y's are outputs. So after we come up with a table, typically we'll be making some tables here, and we graph the equation. The equation is the set of all its ordered pairs, and often will form, if we have an equation, will form, the ones we're going to do will form a straight line, or they could form some sort of curve or other shape. So when we think about a function, think of the function like it's a machine. It takes an x value, you plug it in, you do something, or some things even to it, and it produces, or it produces, that's the output, the y value. That's the number that comes out of the function. So the x values are independent variables. So just like when we made the little graphs yesterday, and on the x-axis we were typically writing time, because time is the independent variable. It keeps going no matter, it doesn't depend on something else. And the y value is the dependent variable. And it's going to depend on what we plug in for x. So we can kind of think of the x being independent because you're picking it. You get to choose. In some cases, we will have already chosen some numbers, but okay. Everyone have notes down there so far? Okay, so we're going to look at some tables of values, and if you already know like about slope-intercept form, you might have another way to graph these points and graph these, but we are going to use the function table in this case because that's kind of what the lesson is about. You should find that slope-intercept form would still give you the same graph when we finish. So when we're graphing these function tables, first, the x's are all the numbers we are putting in to the function. For some of these, you may be able to do it in your head. For some, they may be a little more work. You may want a calculator or a piece of paper, but this is what is happening. So for number 1, each of these x's get a turn going into the function, one at a time. So -5 plus 4 So negative 5 plus 4 is negative 1. So the y is equal to negative 1 when the x is negative 5. Then we go back, and now we're going to put the next number. We're going to put negative 4 into the function. It's going to replace the x. Negative 4 plus 4, the y is 0. I'm going to move on to my next x. That's also my next input. I'm putting it into the function. Notice when it goes in, it replaces the x. So then negative 2 plus 4, positive 2. So when x is negative 2, y is 2. And then last, we're going to do 0. So 0 plus 4 is 4. So that is how we complete the table. And even if the table, sometimes you'll see these tables and instead of y, it might say f of x. That still means the same thing. So everything in the table becomes an ordered pair, and then we're going to plot those points. So negative 5, so that's 5 to the left, and down 1. Negative 4, 0, so 4 to the left, don't go up and down. Negative 2, 2, 2 to the left, and up 2. 0, 4. So 0, don't go left and right, just go up 4. So we're always starting in the center. And notice that they are lying on a straight line. So then this would be considered a linear function. And then we can connect our dots and know that this actually would continue. We only have the values for these specific members of the domain, but any point that this line is going through would also, that ordered pair would make the equation true. So, for instance, 3 1/2, well, that's off the graph. So if I said, if x was 1/2, if x is 1/2, the y is 4 1/2. It would be way up here. But these other places where we see nice corners, like here, that would be negative 1, 3. Is negative 1 plus 4, 3? Yes, it is. So any point that the line extends through is also making the equation, we know is also a point, is a solution for the equation. Now, that one was pretty easy. All we had to do was add 4. The next one, number 2, might make some of you a little nervous because there is a fraction. To handle a fraction, you are multiplying by the top number and dividing by the bottom number. You could also do the division first. So when I look at this personally, I do this, something times negative 4, and I probably would just use the dot instead of a parenthesis, to be honest. And I see the 4s. I do my division first because it keeps the number smaller. So 4 goes into 4 one time, but it is still negative 1. And then 3 times negative 1 is negative 3. And negative 3 subtract 2 makes negative 5. You're also welcome to use the calculator to help with that. But that is why the numbers selected for x are negative 4, 0, 4, and 8. We did not select things like 1 because they would be messy. They would have fractions or decimals in the answer. 0 is always a nice one to use because 0 times 3/4 is just 0, and then 0 minus 2, negative 2. 3/4 times 4. So remember that a whole number is like that number over 1 if you want to write the 1. But it is basically, you could think of it as being in the top. And then whatever our answer is, we're going to subtract 2. 4 divided by 4, that becomes 1. 3 times 1 is 3. 3 subtract 2, 1. And then if I want to do 3/4 of 8, if you don't like the way canceling works or looks, you can multiply across and divide by the bottom. 3 times 8 is 24. 24 divided by 4 is 6. Don't forget, we still need to subtract 2. 6 subtract 2 is 4. All of the tables that we have in this lesson, they are all linear functions. So if after you fill in your table and you plot your points, if they cannot all be connected with one straight line, something is wrong. It could be that you just graphed incorrectly, or it could be that there's a mistake somewhere else. But if they cannot be connected with a straight line, if all of them except one, then you kind of know who's the problem. And it's not a guarantee that you're right if they do, because you could have all of them wrong, I suppose, but it is a helpful confirmation. So -4, -5, 0, -2, 4, 1, and then 8, 4 is off our graph. So 8, 4 would be about here, off the graph, right? So if I just connect my 3 that are on the graph, and if I kind of extend it out there, I could see that yes, it's heading in the right direction to hit 8, 4 if my graph were bigger. So some of your numbers may not fit on the graph, but notice the numbers were carefully selected so that we didn't have decimals to graph. Some of them only have one step. Like number 3, you're just doing 3 times the number. So you may very well be able to do that in your head. But something like number 4, -3/2 times x. Some of you can also do that in your head. Some of you may like using the calculator for that. You would do -3 ABC 2, because the ABC is the fraction bar, times -2, and then do +2. That's the keystrokes that you would type in to type that first thing in. Or you may want to do it on paper, but you're going to be replacing the x with each of these numbers. Take turns replacing the x. Then that table of values becomes ordered pairs that we'll put on the graph. Does everyone have 1 and 2 written down? Okay. I heard no one say, stop, wait. Okay, let's talk through number 4. I think number 3 will be an easier one to do. So for number 4, I'm doing -2. So in your head, these numbers are going to stay pretty small. You could do -3 times -2 is 6. And 6 divided by 2, we're back to 3, but it's positive now. And 3 plus 2 is 5. So I did this. And then +2. The multiplication, remember, comes first. Even if it had been written as 2 minus 3 over 2x, the multiplication times the x value would come first. Negative 3 over 2 times 0 is, of course, 0. And 0 plus 2 is 2. Negative 3 over 2 times positive 2. That would be negative 6 divided by 2, or just simply cancel these out. That would give us negative 3 plus 2 is negative 1. Hello there. Negative 3 over 2 times 4, and then add 2. So I could divide first, or I can multiply first. So negative 12 divided by 2 is negative 6. Or 4 divided by 2 is 2, times negative 3, also negative 6. Add the 2, negative 4. And then we're ready to plot those points, and they should fall in a nice straight line. In number 5 on the back side of the page, the first part of that says negative x. So that means you're going to make x the opposite of what it currently is. So you're going to make x the opposite of what it is, or you could think of that as multiplying by negative 1 and then add 1. So the opposite of negative 3 is 3, and 3 plus 1 makes that 4. And one part of number 6, this part is going to need to happen first. So negative 1/3 times negative 3 would be 1. And then 1 plus 1 is 2. So I'm doing 1 minus 1/3 times negative 3. Or you could type all that into the calculator at one time. Okay, so for the ones with the tables and the graphs, you're going to fill in the table and then plot the points on the graph. They should line up to create a straight line in all of those cases. And then the next ones is basically the same process, except we're not making a graph, and we're just going to make a list. So if it says what is the domain, it says what is the range values, and we're given 3 numbers for the domain, then we should have 3 numbers for the range. So we're just, again, going to take turns. So let's say for number 9, I'm doing y is equal to 4 subtract negative 2. So my first range is 6. I am terrible about making that little symbol, but anyway, my first member of the range would be 6, because plus plus. And then I'm going to do y equals 4 subtract 3, which is 1. And then y equals 4 subtract 5, which is negative 1. Now, if you leave your answers like that, I'm not going to mark that wrong, but I do want you to recognize, like if you saw multiple choice, that this would probably be listed from least to greatest. Okay? You do not have to reorder them for this assignment, but just know that typically they will be listed from least to greatest, so I wouldn't want you to be, think that you had the wrong answer, or not recognize your answer in a list if there were multiple choice. So no graphs to make. You're just going to have a list of your basically a list of your 3 answers. Okay, so I'm going to give you guys some time to work on that. I do want you to finish all the problems on 15 and 16. Please ask if you have questions. If you want to know more about how to use the calculator to handle the fractions, happy to show you that.